So there's a census. They say 16% of the people are of Hispanic origin. So when you see a percentage, you can also think of that as a proportion, right? 16% is the same thing as 0.16. So it looks like we're dealing with just one proportion. I'm just reading through. One person says that they think their county has something different than 16%. So they look at their most recent survey data, which is a random sample of 497 county residents, and found that 41 of those displayed Hispanic origin. Look, there's different numbers here, but there's one proportion, right? We're talking about the percent of our county or our local area or the United States is all talking about the percent this Hispanic origin. So we know that this is a one sample, one proportion z-test. Okay, so that's one of the parts of this question. What's the hypothesis going to be? This person says that they think that it's different. When a county supervisor believes their county has a different proportion. So that means the alternative hypothesis needs to say that their county is not equal to 16%. And that's why this is the correct answer. Because the hypothesis you're trying to provide evidence for is always the alternative hypothesis. So the proportion is not equal to 0.16. That, in other words, is the proportion is different than 0.16. And that's why all these other ones are wrong, because that alternative is not listed correctly. Check the appropriate conditions for the hypothesis test. So we need to make sure that when we do our sample, that our sample is not above 10% of the data set. And we're also supposed to check these two things here, these two quantities. N times P, P sub 0, it needs to be greater than, actually textbooks vary, it's usually greater than 10. And N times Q needs to be greater than 10. In other words, this P sub 0 is saying that your proportion times your sample size, that needs to be less than 10. And then Q is just 1 minus your proportion. Okay, and so to recreate that calculation, 497 is our N, and P sub 0, that's the population proportion. It's 0.16 as a decimal. 79.5, I don't know if they wanted us to round to 1 decimal. And then for N times Q, Q is just 1 minus your proportion. So that's our Q. Multiply that to 497, that's also bigger than 10. So last thing you'd want to check is to make sure that they're independent, which means like you're doing random sampling. Grabbing one proportion isn't going to affect your chances of grabbing a certain other type of, sorry, I shouldn't say proportion. Grabbing one person, surveying them isn't going to impact your chances of surveying another person. So we usually satisfy that criteria by random sampling. Okay, the conditions are met. It's appropriate use in the normal model. So part C says to draw and label a sketch. So we don't have the, it's not like we can plug this stuff into a histogram, but we have this information that the population proportion is 0.16. Let's see our sample proportion. It's quite different. Draw and label a sketch. They didn't explicitly say they wanted what the sketch to be. So usually what they want in these sketches is they want to have it centered at the population proportion because they're trying to do hypothesis testing, right? The population proportion for the United States is 0.16. So since this criteria of the normal approximation is met, that means we're going to have a roughly bell-shaped curve with 0.16 as our center. This 0.082, that would be having our sample to be the center. But what we're doing is we're comparing our sample to the population. It would seem kind of crazy to say, like, we want to see if everyone else is different than our town, right? That would take a long time because we have to go gather everyone else's data. We're comparing the population, 0.16, to our sample. So the population needs to be the center there. So that's why that's the correct choice in graph. I guess those lines are just, I don't know what those are for. Maybe, yeah, I don't know. So to calculate the test statistic, we can use the formula for the test statistic of a population proportion. It is your sample proportion subtracted by your population proportion, which looks to be P sub 0 in our text. and then you divide it by the standard error of the population proportion, which is p sub 0 times 1 minus p sub 0. And then you divide that by n. The n is inside the square root. I'm just writing with a mouse pad right now. So we got to plug our numbers in there. P hat, I've forgotten already. 41 out of 497. 0. I'm going to take a bunch of decimals just to make sure I'm making WebAssign happy. So I'm going to round that up. This is my P hat. Our population proportion, the amount we're trying to compare to, is 0.16. And then we divide that by the standard error. So I'll draw a little square root symbol. And look, in here, sometimes there's confusion because p hat and p sub 0, what's the difference? If you know the population proportion, that's supposed to go in for the standard error. And if you don't know it, you can use the sample proportion to estimate it. Obviously, if we know the population amount, we're sure that that's actually the population amount. That's what we want to use whenever we can. Sample size is 497, I think. My square root is supposed to go over everything, though, so I'm going to drop that down a bit. Okay, so I can do this all at once in my calculator, the standard error at least. I've got 0.16 copied to my clipboard. Oops. 1 minus 0.16 is 0.16, and then I divide that by 497, and then that's scientific notation times 10 to the negative 4th power. So I'm going to take a square root, and there's my denominator. And then my numerator is just a little subtraction. There's my numerator number. And we're just going to divide those two, and then we'll have our test statistic. So it looks like negative 4.71 is our test statistic. I don't know how many decimals they want. 2 decimals. So negative 4.71. And a p-value, we can get that from an online calculator. What we want to do is take negative 4.71, and we're going to go here. I'm going to go to Google, and I'll type in the value to probability calculator. Because p-value is telling you the probability that you get this test statistic if the null hypothesis is true. Look, this one is set up for doing comparing means, population mean. So this one's not really suited for what we're doing. All I want to be able to do is have a calculator where I type in a z value and it spits out the probability that corresponds to it. So this one should work. And then our p-value is the area that's in the tails. Okay, so in that drawing we chose, this is our normal distribution. It's centered around the mean, and we said it was a does not equal to hypothesis test. So that means we have a two-tailed test here. Okay, there's 2 tails. So we're going to find the area of this tail, and the area of that tail is dictated by that z-score, which is something. I forgot. Negative 4.71. So negative 4.71 is the z-score. We want the area to the left, and then we're just going to double that because it's a two-tailed hypothesis test. So let's go to the calculator. Let's do the area to the left, negative 4.71. And if you hit compute, it tells us that little tail that we just drew, well, it's probably further to the left. That's negative 4.71. It should be really small. It looks like it's saying it's 0, which sounds about right, because if you're 2 standard deviations away, you've got a pretty small probability left in the tail. If you're 3 standard deviations away, even smaller. So we're over 4 standard deviations away. It's telling us that we have an area of approximately 0 in the tail. You could try a different calculator too, but I think it's going to say the same thing. Let me just, no, that's between. Okay, that's it. I mean, the area in the tail is so small that our calculator is spitting out 0. So our z value, our p value, 3 decimal places, looks like it's going to be 0. In our conclusion, if your p value is low, reject HO. Okay. When your p-value is low, that means you found statistically significant evidence. We have a low p-value, so there's evidence to reject the hypothesis that our town or our county is equal to 0.16. We have evidence for the alternative, that our our population, our county's proportion is different than 0.16. So the p-value is low. There is evidence that there's a difference, right? Because having a difference was our alternative hypothesis. The p-value is low. We're rejecting HO, and we're going with H1, HA, the alternative. So when the p-value is low, you go with your alternative hypothesis.